Now we're going to take a step to a slightly more advanced aspect of algebraic division. Now, as you know, algebraic fractions are fractions of the form x over y, where you have a numerator and a denominator, and there's a variable present in the numerator or in the denominator. So it's something like this, or something like this, or something like pz over 2. These are all algebraic fractions. They involve variables. Now, you can multiply the numerator and the denominator of an algebraic fraction by the same term, and it's a valid mathematical operation. It changes nothing when you do that. As if I just say, okay, I want to multiply the numerator by 5 and the denominator by 5. This gives 5x over 5y. This is a valid operation, and I'm going to prove later this 5x over 5y, the result obtained, is the same thing as what we started with, which was x over y. You can also divide the numerator and the denominator of an algebraic fraction by the same term. So say we have x over 4, or let's say we have xy over x. We can say, let's divide the numerator term by x and also divide the denominator term by x. It's a valid operation, and you see how they come in handy shortly. But essentially, when you're carrying out algebraic division problems, you usually need to simplify your expressions, and you can use these two techniques I just discussed to simplify algebraic fractions. You see them shortly. Finally, you can always use the laws of indices where possible. So the laws, as we've just seen, are especially the ones pertaining to division. For instance, you have the law which says x to the power of n divided by x to the power of m is equal to x to the power of n minus m. I think this is the most common law you'll use. You also have expressions like 1 over x is the same thing as x to the power of minus 1, or x to the n, same thing as 1 over x to the minus n, or x to the minus n, the same thing as 1 over x to the n, and so on. So you can feel free to go to the videos which cover the laws of indices pertaining to algebraic division before moving on to the next section. So here's an example. We're asked to simplify the given expression. And the expression we have is 2x over x, which is the same thing as 2x divided by x. But we're given the expression 2x over x, and we're required to simplify it. And there are many approaches we can use. One thing to note is that you can rewrite this fraction as follows: 2 times x, so 2x is 2 times x, and the numerator remains x. You can also write this as 2 times x over 1 times x. X is the same thing as 1 times x, so I haven't changed anything. We want to simplify this expression, so how can we proceed? One way is to say, okay, I'm going to form a fraction, these two, with this numerator term and this denominator term. I'm going to form another fraction with this numerator term and this denominator term. As you've seen in the previous video, this technique is just a case of re-expressing the original fraction we had as a product of two fractions. And this gives 2 over 1 times x over x. As you know, x divided by x is 1. So, and 2 over 1 is 2. 2 divided by 1 is 2. So this is the same thing as 2 times 1, which is 2. So that's one approach. Another approach is to have our original expression 2x divided by x. Now we have a fraction, and the expression will be simpler if we just had a whole number or some expression that wasn't a fraction. And we can achieve this by getting rid of the x in the denominator. And this can be achieved by dividing x by x. But if we want to divide x by x, we also have to divide the numerator by x. So if we divide the denominator term by a term, we have to divide the numerator term by the same term. So I'm going to do that. Now, the numerator divided by x is 2x over x. That's our numerator. The denominator divided by x is x divided by x. That's our denominator. Now, as you can see, x, you can basically say x cancels x, or you could say x divided by x is 1, but x cancels x to give 1 behind, and you can do the same thing here. X cancels x to give 1, I could do the same thing here. You have 2 times 1. Instead of 2 times x, you have 2 times 1 as a numerator term. And this simplifies to give 2, which is the same result you got here. Now, what I did here might not make sense now, but as I do more examples, you'll fully appreciate the technique. Here's another example. We're required to simplify the expression 2x squared over x. One approach is to write the fraction out as follows. 2 times x squared divided by x, which is the same as, instead of x, write 1 times x, because 1 times x is x. This is one fraction. It's another fraction. So the original term can be written as 2 over 1 times x squared over x. So what we're doing is we're writing this term, this fraction, as a product of two fractions. So just to highlight the fractions we used. Now moving on, this is what we have. 2 over 1 is 2. X squared over x is x to the power of 2 minus 1, because this is the same thing as x to the power of 1. Remember, x to the m over x to the n is x to the m minus n. So 2 times x to the 2 minus 1, which is x to the 1. 2 minus 1 is 1, which gives 2 times x, which is 2x. Here's another example of an algebraic expression which needs to be simplified. This expression can be written as 6 times x cubed, 6 times x cubed divided by 1 times x squared. And as you know, when you have a situation like this where we have, say, a fractional form a times b divided by c times d, so a fraction where the numerator is a product of two terms and the denominator is a product of two terms, or even two or more terms, you can form fractions as you wish, and you can express the original expression as a product of the two fractions that you form. So forming fractions, we can group the x's together and 6 and 1 together. This gives 6 over 1 times x cubed divided by x squared. 6 over 1 is 6. X cubed divided by x squared is x to the power of 3 minus 2. So we have 6 times x to the power of 1, which is 6x. And we're done. Here's another example. We have this expression and we need to simplify it. Again, we express the numerator out. We write out the product and we include the multiplication sign. So 3xy is 3 times x times y. X is same thing as 1 times x. And we can say times 1. What I've done is try to cause denominator to have 3 terms to match with the number of terms in the numerator, because it helps us when we're forming fractions. This, form another fraction like this, and form a fraction with just the x's. Now we have 3 over 1, this first fraction, times x over x times y over 1. 3 over 1 is 3x divided by x is 1, y divided by 1 is y. So what we have here is 3 times 1 times y, which is 3y. So this expression has been simplified to give 3y. Here's another example. We need to simplify this expression. I'm going to write it out as x squared times y divided by y squared times x. I could rewrite this as x squared times y divided by x times y squared. Y squared times x is the same thing as x times y squared. The order in which the multiplication is carried out does not matter. Now I'm going to simplify, break this down to two fractions. This is one, I'm grouping the x's together. This is another, I'm grouping the y's together. And this gives me x squared over x times y over y squared. And using the rule, x to the m divided by x to the n equals x to the m minus n, or y to the m divided by y to the n, suppose y to the m minus n, we get this as x to the power of 2 minus 1 times, so this is y to the 1, y to the power of 1 minus 2. This gives x to the power of 1 times y to the power of 1 minus 2 is minus 1. So we get x times minus 1, which is x is minus 1. And you know from one of the laws of indices, x to the minus n is 1 over x. Therefore, or x to the power of minus 1 is 1 over x power of 1. Remember, when you have an expression like x to the power of minus n, you can write it as follows. You take the reciprocal, so of x, which is 1 over x, and you raise it to the original power times minus 1, which is what we have here. I'm pretty sure you remember this rule. It's one of the laws of indices. So doing that here gives x times, instead of y to the power of minus 1, we have y to the power of minus 1 is 1 over y power of 1, which is x times 1 over y to the power of 1. Anything to the power of 1 is itself. Remember, a to the power of 1 is a. So 1 over y to the power of 1 is 1 over y. So this is the same thing as saying x over 1 times 1 over y, which is x over y. X times 1 is x, 1 times y is y. So we've gone from this nasty looking expression to something that looks simpler, x over y. Here's another example. So we need to simplify this expression. We write out the numerator, 14 times x divided by 2, which is the same thing as 14 times x divided by 2 times 1. The reason why I've written 2 in this form is so that I can have 2 terms in the numerator and 2 terms in denominator. 2 times 1 is 2, so I haven't changed anything. Now I'm going to form 2 separate fractions. Here's one fraction, and here's another. So we have 14 divided by 2 times x divided by 1. 14 divided by 2 is 7, x over 1 is x. So we have 7x. So note the distinction between the multiplication sign and x, the variable. The multiplication sign I write as an x. X I write with this curved lines. So x, multiplication sign, and x. So you can see the difference. One is curved and one uses straight lines. As you can see, this expression has been simplified to give this. So we've gone through so many examples, and the reason is because this algebraic division technique can be hard to grasp at first, but after solving or going through a lot of examples, you should easily grasp the concept. It's just one of those things that takes a lot of practice.